Sir, I can.
Okay, see, as I was going through assignment, see, Habib, see, you had to add 7 upon 10 and 3 upon 4. What is the LCM of 10 and 4? Yes, the LCM of 4 and 10, you have
40.
written it is 40. No. How have you got it? Can you show me the rough page in which you have written this? How you did the calculation?
20.
It's 20 now?
Yeah.
It is 20. So you have done a basic mistake in this, because of which all the other process in this question it is wrong. Then we have one similar question, 1 upon 4 and 5 upon 8. Here you have found the LCM to be 16. That is again false. That is not correct. Even if you were to just write the multiples, 4 ones are 4, 4 twos are 8, 4 threes are 12, and so on. 8 ones are 8, 8 twos are 16, 8 threes are 24, and so on. Here we can simply see that the lowest common multiple is 8 simply now. And you have written it is 16, so that is again wrong. So you're making mistake in LCM. And I suppose that we have forgotten the concept of HCF also. So you need to revise the previous chapters also. Okay, occasionally there will be questions in your book from HCF, LCM. So occasionally you can solve questions from that. Or if you happen to have any workbook apart from the main course book, you might, if you have workbook, so you can solve question from that also. Do one thing, for the first 5 or 10 minutes you are going to solve questions on LCM and HCF only, then I'm going to continue further. Okay, that is one thing. Okay, also the other things which we have learned, the geometry and the place value system, so revise those things also. Already we had revision classes, but it is important you take out some time to revise that. You tell me, for how many hours do you do the self study? After 1 hour class, 1 hour of class, for how many hours do you study mathematics at home? Yes, Abhi, repeat.
Half and
Just half an hour. That is not sufficient, Habib. You actually need to study for about 2 hours mathematics a day. Apart from the class, you need to, like, in just half hour, in that just half hour you'd be only solving the assignment, I suppose, right? The half hour you're seeing that, in that you'd only be solving the assignment. If that is the case, then I'm going to multiply the number of questions. If I will have been giving 10 questions, now the number of questions will be 20. That's the way how you'll be getting to practice more questions. Okay. Now find the LCM of these numbers. I'm listing down some numbers. You have to find the LCM. Also, if your mom's there, I recommend you also that take help of your mom and ask her to download some of the workbook. I will send the PDFs of some of the workbook. Okay, I will send it to the team, or I will directly send it to you, and you will be required to solve in your extra leisure time. You will be solving questions from that. Take care, Habib. In the leisure time, you will be solving questions from those exercises. I have some PDFs. I will be sharing it after the class to you.
okay.
Okay. So find the LCM of these numbers, 78 and 13. That is the first question. That is a simple question, in fact. Question number 2, find the LCM of 185 and 5. Okay. Just take 15. Third one is 89 and 21. Find the LCM of these three numbers, these three questions. You can use whichever method you like. Okay. Have we done with any of the questions?
Sir,
Mhm.
in finding 78 and 30 is LCM, can I use 13 number?
Yeah, of course you can use 13. 13 is the prime number, you can use it.
I'm getting the LCM 78
Well
for the
done.
first one.
That is correct, in fact. So LCM is 78. Very good. Do the other one. Yes, Subib. Done with the other one. See, I have shared a workbook with you. I have now shared a workbook with you, and on a daily basis, apart from the assignment, when you'll be getting the time for it, try to get the time, take out some time for it, and at least solve questions from each page on a daily basis. On the number, I have shared the workbook. Okay, tell me what number you have used to divide 185 and 15.
Its answer LCM for the second one is
Hmm.
555.
Well done, that is correct. So that will be 555. Okay. Now find the last one also. Also, Habib, the mistake which you have done in the previous assignment, redo that one, redo this one, and the new assignment which will be uploading now, attach the answer to this in the new PDF. Okay, now attach this with the new assignment. I will be checking all of it together. Okay.
This old this
The,
assignment I have to do. Correct.
yeah, yeah. Question number 2, and there was one more question. This question number 4. Redo this one and make sure you write the correct answer in the new assignment also. Okay, no? Yes, done.
All
Okay.
Is it 441?
441. No, that is not correct. How are you getting it? The number 89 and 21. First of all, we are going to divide it with. Can 89 be divided by any prime number?
9.
How can it be divided by 9? 9 nines are 81, 19s are 90. 89 does not come in the table of 9 now. How can you divide it? Habib, I think you have done a mistake in this one. So it will not
Wait,
be divided.
again, I'm doing it.
Okay, do it again. It will be left as it is since it's a prime number. Yes, Abhi, by now you should be done. Do it fast.
1869.
Well done. That is correct. So the LCM is 1869. So it is simply, it will be left as it is 3 7 so 21. So the LCM will be the multiple of these three numbers. 3 multiplied 89 multiplied 7. That is simply 21 multiplied 89. So that is 1869. Okay. Now solve one question on HCF also. Then we are going to continue with multiplication and division of fractions in today's class.
So can you give me one example of HCF?
Okay, sure. Say for example, you have numbers like 144, and you have number like, let us say, 12, for example. You have to find HCF of 144 and 12. So 12 ones are 12, right? 12 ones are 12. So we are going to subtract it from this. So thereby you will be left with how much? 2 here,
22. And 4 from them.
24 now.
12 2s are 24.
12 to 12 twos are 24 then. So simply you are having 12 twos are 24. So in this case, the HCF of the two number is 12. Let's take, for example, we have some other numbers. Let's say
We
we
can
have,
also find HCF by division.
yeah, by the division method, we can find it out. Okay, no? Okay, let's take let's take an example to find the HCF of two numbers. Say we have another example. Let's say we have 1530 and we have, for example, 15. Okay, we have to find the LCM of these two numbers. 1530. 15 ones are 15. 15 ones are 15. So thereby you'll be left with 3 here. After this, we're going to take which number? We're going to carry out this. We're going to continue with this 15 here. Right now.
For that, we should put 0 on top.
Or actually, in order to find the HCF, we should be actually beginning with the smaller number first. Like in this one, you'll be getting confused if you were to continue with that one. So let's take some other number. Say that we have numbers like 242 and we have 46. 46 and 242. To find the HCF here, we are going to divide the larger number by the smaller number. That is 242 will be divided by 46 here. Okay. So what number should I take first? 46 ones, like will the number 242 come in the table of 46? 46, 242, is it a multiple? Let's find it out. 46 times 5 equals to?
Fours are.
No, 46 fours, we are not going to take that. That one will be very small. 46 fives are 230. Okay, Habib, 46 fives are 46 6 are, it will be 276. So that will be a bigger number that we can't take. So we are going to take 230 and subtraction will be getting 12. Okay. So we are getting 12 now. Now we know that as per the rule here, the divisor will become the new dividend. What is the divisor here? It is 46. 46 becomes the new dividend here. Okay. 12 fours are 48, so we can't take that. We'll be taking 12 threes now. So 12 threes are 36. After subtraction, you are left with 10. Okay. Now which number should we take as a dividend? 12 or 36? 12. So 10 ones are 10, and now I'm left with 2. And again, we'll be writing 10 here. 2 5s are 10. Now finally, the remainder is 0. There is no remainder left. So the last divisor becomes the HCF of two number. The HCF is 2. What is Habib, how it has to be done?
Yes.
Okay, on this basis, then I'm going to give you some questions here. So let me just erase this one first. So find HCF of the following numbers. Question number 1, let's take 20 and 45. Question number 2, Take 78 and 42. Okay. Then take question number 3 as 48 and 36. 48 and 36. Or let's take one more number. Let's take 36 and 60. Find the HCF of these four numbers, of, of these four questions.
So for the first one, it's 5.
Very good. By the way, meanwhile, as you're solving this now, answer this question to me. The What is the HCF of two prime numbers? What is the HCF of two prime numbers? Your options are it is 0, it is 1, it is 1 upon 2, it is, it can be any number. HCF of two prime numbers.
1.
It is 1. Can you give an example of this? Give an example. How is it 1? Prove this.
Because they are prime numbers, they don't have any multiple of their own numbers.
They have multiple. They have unlimited number of multiples. They have only two factors, 1 and the number itself.
1 and the number.
Okay, now multiple is different thing. Multiple, when you read the tables, you are reading the multiple of the number. Okay, and the numbers with which it will be divisible and will leave the remainder 0, that is called as the factor. Okay, Habib. So take for example 5 and 7. So their factors are 1 and 5 only, and this one is 1 and 7 only. So the only common and the highest common factor is 1 only. Okay, continue. For this one, you have answered 5. That is good.
Second one, 6.
Well done. That is correct.
Third one, 12.
Third one, 12. Well
12.
done. Very good. Fourth one is also simple.
It's 12 again.
It's 12 again. Good. So that is it. Now, how about if I were to give you more than two numbers? Let's say now you have 60, 84, and let us say 108. Now find the HCF of these numbers. If you have more than two numbers, then how you're going to find the HCF? How you're going to find the HCF of more than two numbers?
I'll do it.
Okay, do it. By the division method, you know how you can do this? You can do this by the division method also. Yes, Abhi. And
How?
we can do this by the division method. Okay, let me tell you. Say, first of all, let's find the HCF of two numbers from this. Let us say that we are right now going to find the HCF of 84 and 108. And whatever I will be getting the HCF, suppose I get some value. I get the HCF of these two numbers. After that, I will be finding the HCF of 60 and 60 and the number which I will be getting here. So in the first step, 84 and you have 108. 84 ones are 84. 8 minus 4 is 4. 10 minus 8 is 2. Now let's take 84 here. We'll be taking 24 threes are 72. I'm left with 12 here. 12 twos are 24. So what is the HCF of 84 and 108? It is
12.
12. So in the step number 2, we'll be finding we have to find HCF of 12 and the number which was left earlier. That is 60. You find the HCF of 12 and 60. Okay now?
Is equal to 12.
Equals to 12 exactly. Right now? So thereby, the final answer you're getting is 12. So 12 is the highest common factor of all these three numbers. Understood this now?
Okay.
Okay. So that is the way how we are going to find it out.
Can you give
I'm
another
going to,
question?
yeah, sure. I'm going to give you one another question since we have already done this one. So you can take these numbers, find HCF of 126, 126, 162, and 180. Find it out. Also, the workbook which I have sent to you, from that workbook, you will be required to solve questions from each page, at least on a daily basis, solve questions from each pages. Okay. And wherever you'll be having difficulty, you can let me know in the class. You can group any two numbers. You can find HCF of 126 and 62 first, and you can take 162 and 180, or you can take 126 and 180. Any two of them can be taken together to find the HCF. Then later you can find the HCF of the other set. Yes, Habib, are you having difficulty in this? Okay, continue.
HCF is 18.
HCF is 18. Well done. All HCF of all three numbers you have found? Very good. In fact, it is correct. Can you show it to me how you have done it?
It's a messy.
Yes.
It's very much messy.
No issue. Just I'd like to see whether you have done the complete process, how you have done it.
First, I divided 162 by 18, 180.
Okay. Then what was the HCF you were getting for these two numbers?
18.
18. And then you took?
18, 7,
And?
126.
Okay, so then you took 18 and 126, right? Okay, so you'll be getting 18. Very good. Okay, so we have learned about that. Now, today's topic is about multiplication and division of the fraction. So give the topic multiplication of fraction. Multiplication of fraction. Write down the topic. So the multiplication of the fraction is not like addition or subtraction of the fraction, where the denominator has to be same. In the case of addition or subtraction, what we have learned, to carry out addition subtraction, the denominator has to be same. If it is not same, it has to be made same. But in the case of multiplication of fraction, here any two fraction with different denominators, in fact different numerators, can easily be multiplied. The only thing that we will have to keep in mind is that the fraction should not be in the mixed form. They should be either in the proper fraction or should either be in the improper fraction. Getting the point what I'm trying to say?
Yes.
So I'm writing some important points that any two fractions can be multiplied, any two or more than two fractions. Okay, so any two fractions can be multiplied even if they have different denominators, or whether they are like or unlike fraction. Like or unlike fraction. Take for example, we have a fraction 1 upon 3 and we're multiplying it with the fractions 3 upon 5. So the step number 1 which we are going to follow here, we are going to first multiply the numerators. Step number 1 says that multiply the numerator first. What is the numerator in the given fraction?
Numerator in the given fraction 1 and 3.
1 and 3. So 1 multiplied with 3. Step number 2 says multiply the denominator. Step number 2, it says that you have to multiply the denominator. Denominator is 3 and 5. So 3 multiplied 5. And simply write down the final answer. That is 3 upon 15. Here we go.
That's it.
But that's not all. Here we're getting to see that the number is not in the simplified form now. We have to simplify it. 3 upon 15, is it in
See,
the...
1 upon 3.
It will be 1 upon 5 actually.
Huh?
1 upon 5, no, 3 5s are 15 now. 3 5s are 15. Like if I were to break it down, like 3, we can write it as 1 multiplied 3. 15 can be written as 5 multiplied 3. If you have same number in the numerator and denominator, you can simply cut it, cancel it, and you are left with 1 upon 5. Got this or not? So it is basically 1 upon 5. And why we are doing it? Because we have to write the answer in the simplified form, in the simplest form, where the only common factor of numerator and denominator is 1. The only common factor of 1 and 5 is 1 now. Is there any other number? No. But earlier it had a common factor other than 1. See, 3 was a factor other than the 1 now. Got this, Habib?
Yes.
So that is the case in the step number 3. What we have to do, step number 3, if the fraction is not in the simplest form, then simplify it. If the fraction is not in simplest form, then we
So,
simplify it. Yes, Habib.
so what is after different denominators or?
Multiply the denominator. Okay, here.
Yeah.
Or whether they are like or unlike fractions. Whether they are like or unlike fraction. Complete this quickly, Habib.
Okay.
Just write down this important point and then write down the 3 steps. Step number 1, multiply the numerator. Step number 2, multiply the denominator. Step number 3 says that if the fraction is not in simplest form, then we simplify it. After this, we'll be learning about some other rules of the multiplication of fraction. Like if the fraction is in the mixed fraction, then we have to convert this into the improper fractions. Then only we continue. Thereby we'll be further also we'll be learning about what if the fractions are having the same denominator, how we have to do the multiplication in case of like fractions. And in the case of multiplication of fraction with a whole number also we are going to learn. So write down this thing quickly. Yes, Habib, done. Okay. Just 1 minute. I'm trying to connect to the camera. Don't know. There's some issue with the cable. 1 minute. Okay, anyways. Now give the next topic. Write down the next topic, which is that rules of multiplication. Rules of multiplication of fraction. So the first rule says that if the fraction is a mixed fraction, then we first convert it into into improper fraction. So then we first convert it into improper fraction. Then only we will be continuing further. After this only we'll be multiplying the fractions. Take for example, you have a fraction like 3 1 upon 4 and you have 7 1 upon 5. So before we multiply it, we have to convert it into the improper fraction. Tell me, 3 1 upon 4 will be in after converting it into improper fraction, what will it become?
Yes.
Tell me.
Yes.
3 1 upon 4, it's a mixed fraction. You have to convert this into an improper fraction. So after converting into the improper fraction, what will it become? 4 3s are 12, 12 plus 1, 13, 13 upon 4.
Yeah.
That will be, another one will be, tell me.
Another one, 5 into 7 is equal to 35. 35 plus 1, 36.
36 upon 5. Now we have to simply carry out the multiplication here. Okay. So we'll be simply multiplying it. Numerator will be multiplied with this 13 times 36 upon 4 times 5. Okay. So 36 times 13. Multiply this quickly. 360 plus 108. So that will be 468 upon 20. So that is your answer. But if it can be simplified further, we'll be simplifying it. Right now, this is not simplified, Habib. Okay, na? So we'll be dividing it further. But anyways, that we'll be learning. That we'll be doing and while we will be solving questions that we'll be doing later. Okay. That is one of the rule of multiplication. Another rule of multiplication says that if any given fraction is multiplied with the 1, so thereby the result will be the same fraction. So any fraction multiplied with 1 results in the same fraction. It gives you back the same fraction. That is one thing. Write down these points quickly. Write down the first and the second point quickly.
Should I write that?
No, don't write the example, just write the points. Example is understood itself. There's one more rule which says that in order to multiply the fraction, we can first reduce the fraction among themselves. We can reduce the fraction among themselves, meaning that stop there, Habib, and listen here what I'm saying. I'm saying that before we carry on the multiplication further, we can simply reduce them in the first place, right? Like in this question, we are going to reduce it, we are going to simplify it after we have got the final answer. But if possible, if we can reduce the fraction before multiplying it, we can do so. For example, take the example, you have 12 upon 6 multiplied with 9 upon 18. So they are not in their simplified form now, so we can simplify it further right now. So 12 upon 6 will be 2 upon 1, and this will be 1 upon 2. So that is 2 upon 1 multiplied 1 upon 2. After multiplying, it will be 2 upon 2, and you are getting 1 here. So we have simplified them in the first place. 12 upon 6 simplified to 2 upon 1. 9 upon 18 simplified to 1 upon 2. Got this now? So that is also one thing. Okay, continue writing it.
Should I write the third rule also?
Okay, third one I'm going to write the write the note for this. Okay, now. So we can simplify the fractions first. We can simplify the fractions first, and then multiply to get the final answer.
Should
Done?
I write the other?
No need to write it. Now solve some of the questions. We're going to practice some questions now. Okay, the first one, I'm going to do this one for you. See, an important rule which I'm going to teach you in this one here. Now, while we are multiplying the fractions, we look at the numerator and the denominator of the alternate fractions. Look at the numerator of the first fraction and look at the denominator of the other fraction. It is 82, it is 44. Right, Habib? Now, can we cancel out 88 by 44? 44 twos are 88 now. Can we do so? See, as per the rule, what I'm saying here, if you have a fraction like this, like this is the numerator, this is the denominator. Numerator 1, denominator 1. Multiplied numerator 2 upon denominator 2. If the numerator 1 can be cancelled out by the denominator 2, will be cancelling it out. If these two cancel out each other, we can cancel them. Or if the numerator of the other fraction or the denominator of the first fraction, if they cancel out each other, we can cancel them. Like here, the denominator of the first fraction and the numerator of the second fraction, will they be cancelling out each other? Both of them are same now?
Yes.
They will cancel out each other. 12 ones are 12, right? So this 12 and this 12 we can simply cancel out here. We can cut them like this. Got this? What is left? 1 is left here, 1 is left here. If nothing is left, so it means 1 is left here. 44, 2s are 88, and here 1 is left. So at the end, what we are left with? In the numerator, you have 2 and 1. So you are going to multiply the numerator. In the denominator, you are left with 1 and 1 on both the fractions, right? Multiplied 1 with 1. So that is 2 upon 1, or simply it is 2. You understood what I have done here? Habib, you got this thing? Okay, good. I'm going to give a question on similar pattern. It is 36 upon 19 multiplied 38 upon 6. Here the numerator of the first fraction will be getting cancelled out by the denominator of the second fraction. And here the numerator of the second fraction will be getting cancelled out by the denominator of the first fraction.
So what should be cancelled?
Repeat again.